Why does Saturn have rings? What are the different types of clouds? How does an octopus swim? Why does a tiger have stripes? How do flowers grow?
Tell Me Why. The Video Encyclopedia is a reference work that's designed to show the answers to questions that young people ask. All materials used in this work are based upon the best-selling book series by Arkady Lyokum.
What is electricity?
Electricity is the most important source of energy that exists today. Thanks to electricity, you are able to warm and cool your home, cook, telephone your friends, dry your hair, and watch TV. Electricity is a very important part of our lives and one that we often take for granted. Electricity always existed, naturally throughout our universe. But it's only within the last 100 years or so that we've learned how to control this great natural resource and use it to our benefit. The ancient Greeks observed the presence of magnetic forces between pieces of black stones called magnetite. The 17th century was an important time for electrical discoveries. Scientists first began to control electricity with the invention of the Leyden jar, a device which could collect and store electric charges. In 1752, Benjamin Franklin proved that lightning was the result of electrical forces in nature when he flew his kite in a thunderstorm and collected electricity in a Leyden jar. In 1831, English scientist Michael Faraday discovered that the electricity that occurs in nature can be created by rotating magnets within copper coils. Since then, great advances have been made in the control and distribution of electricity. Understanding what electricity is and how it works will increase our appreciation of it, as well as help us to use it more wisely and efficiently. Electricity is caused by the attraction that exists between tiny atomic particles. Everything in our universe is made up of tiny things called atoms. The center of each atom, called the nucleus, is made up of protons. Each proton has a positive charge. Orbiting around the nucleus at very high speeds are particles called electrons, which have a negative charge. In some substances like copper, aluminum, or silver, the orbiting electrons are very loosely held, and atoms that touch one another may actually exchange or trade electrons. This flow and exchange of electrons from one atom to another creates electricity. These substances which allow this flow of electrons are called conductors.
How is electricity made?
This electricity that occurs so naturally can be created and controlled to serve us as we need. This is what goes on in a power plant. Generating electricity is based on Michael Faraday's one simple scientific principle. Whenever a conductor, like copper, moves through a magnetic field, electrons are exchanged and an electrical charge is created. In a power plant, energy is used to turn the blades of a turbine, which is like a large fan. Connected to the turbine in the generator is a rotor magnet, which also turns, creating a changing magnetic field. A conductor wire, like copper, is attached to the magnet. The atoms in the conductor wire are stimulated and begin exchanging electrons, which creates the electrical charge. This continuous flow of electrons is called a current. The electric current flows out of the power plant through transmission and distribution wires and brings the power directly to your home. When the electric current leaves the power plant, it has a simple goal: to be used where it is needed. The electric current travels through power lines to whatever requires electric power, and the rest travels back to the power plant through return wires. This circular path is called a circuit. But before the electrical current completes that circuit, it makes a few stops. After the electrical energy leaves the power plant generator, it travels to a step-up transformer. The transformer raises the electrical pressure of the current. This pressure is called voltage. The current will need this voltage increase to help move it through the transmission lines to distant places such as your home. The pressure of the electric current leaving the transformer may be as high as 765,000 volts. Because the electrical current leaving the transformer is at a very high voltage, it must be carefully controlled. One of the ways in which this is done is through the use of insulators. Insulators are substances whose atoms do not easily give up their electrons. This makes it difficult or impossible for an electric charge to be produced in insulators. Glass, rubber, plastic, and paper are good examples of insulators. Transmission wires are wrapped in an insulator to keep the electric current in its proper path. And that's also why appliance cords are coated in rubber, to keep the electricity from escaping. As the electrical current continues on its journey to your home, it also stops at a substation, where a step-down transformer lowers the voltage. At the top of the poles in your neighborhood, you can see pole transformers. They reduce the voltage to either 120 or 240 volts. The voltage must be lowered so that the electricity can be safely used in your home. Finally, as the electricity enters your home, the current passes through a fuse or circuit breaker. These are protective devices that prevent too much current from flowing into your home. If too much electricity is flowing into the fuse switches off, breaking the circuit and stopping the flow of electricity. This protects against power surges that could damage the electrical wiring and appliances in your home. The overall circuit that runs from the power plant to your home is made up of a number of smaller circuits. For instance, the circuit that goes from the power plant to a transformer, or even from a wall socket in your home to an electrical appliance. The electrical current always flows out and back. There are two basic types of circuits within your home: a series circuit and a parallel circuit. In a series circuit, all the current in the circuit flows through each lamp or appliance. If one bulb burns out or is turned off, the circuit is broken. Current stops flowing and the other light bulbs on the circuit will not burn. This type of circuit isn't very common because it's obviously not very practical. However, some series circuits are used for safety reasons. A good example of a series circuit is a string of Christmas tree lights that don't work if one of the bulbs is burned out. The second type of circuit is much more common. A parallel circuit divides the current flow through each light bulb or appliance in the circuit. In a parallel circuit, if only one bulb burns out or is shut off, the overall circuit is not broken and electricity will still flow to other bulbs.
Why does the light go off when you turn the switch?
You can see a parallel circuit at work when you switch on a light. When a light switch is in the on position, the circuit is completed, and the current flows into the bulb and back out. But when the switch is off, the circuit is broken, and the flow of the current is not completed all the way to the bulb. If the delivery wire and the return wire of any circuit are accidentally brought together, a faulty flow of current occurs, and the result is a short circuit. The electrical power moving in the delivery wires is interrupted before it has a chance to be used up. This power is then rerouted to the return wire, which is not equipped to accept the high voltage. This sudden overloading of power can result in damage to your appliance or electrical system.
What are AC and DC?
All these currents possess what is called alternating current, or AC. In AC, the current flows out through the delivery wire to the appliance, then returns through the return wire and gets ready to start all over again. One complete circuit is called a cycle. In most instances, 60 of these cycles occur each second. From this, we get the term 60-cycle AC. We usually call cycles per second by another measurement name, a hertz. Most of the appliances in your home are designed for AC only. There is a second kind of current called DC. DC stands for direct current. The current flows out in one direction but does not return, so there is no complete circuit. DC is the type of current used in batteries. The electric current flows from the battery to the appliance being powered, like a flashlight or a portable radio. When all the houses and buildings in a community require more electricity than the power plant can provide, the plant may reduce the overall voltage that it's sending out to the community. With this reduced voltage, your appliances may not work as well, and your lights may go dim. Though this may seem an inconvenience, it's being done to protect the power plant from shutting down. If the power plant did not reduce its voltage, the power might shut off completely and a blackout could result. A blackout can occur in one of two ways. When the demand for power is too great in a community, a transformer may shut down and break the circuit because more power is trying to make its way in than the circuit can handle. Or a blackout can be caused by some damage to a transformer, such as a car hitting it, or lightning striking it during a storm. In this case, the circuit traveling through the transformer is broken, knocking it out of service.
What is static electricity?
Almost all objects can be electrically charged, even a person. When two objects with opposite charges attract one another, an electric charge is created. This charge is called static because it does not move like an electric current does. The most common example of static electricity occurs when you rub your feet across a carpeted floor. Your body loses electrons and becomes positively charged. When you touch an object or another person's body, the imbalance of electrons results in a small electric charge. Lightning during a thunderstorm results from the same imbalance of electrons. Thunderstorms form as warm air moves upward in strong currents. These are met by downward flowing cold air. When this happens, some atoms lose electrons and become positively charged, while some atoms gain electrons and become negatively charged. The negatively charged atoms in the clouds are attractive to positively charged atoms on the ground. This electron exchange between the cloud and the ground results in an electric charge we call lightning.
How can I be safe when I'm using electricity?
The most important thing to remember about electricity is one simple fact. As it moves, electricity is always seeking the ground. And it will take the easiest, shortest route it can find to get there, even if that route is you. So remember to play it safe around electricity. We'll tell you some ways you can do that. The distribution wires in your neighborhood are a good place to start. These overhead wires are usually bare or are only insulated for protection against weather. Remember, they carry an extremely high voltage that could be very dangerous if you were to touch them. If you're climbing a tree, look around to make sure that there are no distribution wires running through the branches. Remember, if you were to touch one of the power lines while in the tree, it would provide the electrical current with a quick route to the ground through you. If you're flying a kite or a model plane, stay away from the transmission and distribution wires and poles. If they get tangled in an overhead wire, you'd again provide the electrical current with a quick route to the ground. If your kite does get caught in a transmission or distribution wire, don't touch the string or try to pull it loose. Call the electric company. They'll take care of it.
What happens if a wire breaks?
Occasionally, outside forces will cause a wire to fall to the ground. If you see this happen, stay away and keep others away as well. The wire may still have current flowing through it. Remember, call the electric company immediately. Climbing utility poles isn't smart either. If you touch the wires, your body and the pole are providing the electrical current with a passage to the ground. Moreover, the shock of the voltage surging through your body can be so great that it can loosen your grip. If that happens, you are also in danger of becoming seriously injured from your long fall to the ground. If you're ever doing any work on the roof of your house, be careful. You are much closer to the wires up there, so take a look around and see where the wires are. This will help prevent any careless accidents. If you have an antenna on your roof, be sure that it is a good distance away from any wires. A strong gust of wind might knock it over, and you wouldn't want it to hit the power lines. Ground transformers and substations can be dangerous places as well if not treated with respect. Transformers are marked with danger high voltage signs. Believe it. Those signs are there for your safety. If you lose a ball or frisbee behind the transformer's fence, don't go after it. Call the electric company.
What is lightning? Is it electricity?
Lightning is a form of electricity, and it too results from the attraction among tiny atomic particles. When masses of warm air meet masses of cold air, an electron imbalance between the clouds and the ground occurs. As nature tries to correct the imbalance, lightning results. Benjamin Franklin proved that lightning was electricity in 1750, when he performed his famous experiment of flying a kite during a thunderstorm. Although Ben made an important discovery, his experiment was very dangerous. He could have been electrocuted. Water is a very good conductor of electricity. This means that electricity moves through water very easily, and when you get wet, you could become a prime route for electrical current. That is why it is wise to stay indoors during an electrical storm. It is also wise to stand away from trees or poles during an electrical storm. Lightning can easily strike the tree and send the current into you. Indoors or outdoors, you must also be very careful when operating any electrical appliance near water or when it is wet.
Am I safe from the dangers of electricity indoors?
Safety with electricity requires even greater care inside your home. Because there are so many electrical appliances, you are much more closely exposed to electricity there than outdoors. First, let's look at how electricity enters your home. Not only is it easy to understand, but it can save you from electrical accidents. Electricity runs from the outside power pole to your house along a service drop wire. It enters your house over a series of 3 wires. From there, it flows into the fuse box or circuit breaker panel. This is the main electrical control center in most homes. From there, it flows out different electrical wires which form separate circuits for different parts of your house. When too many appliances are being used at the same time on one circuit, the overloading may cause the fuse to blow or the circuit to break. When a fuse blows, it breaks the circuit in order to prevent too much electrical current from flowing into the wires. If the circuit did not break and the current continued to flow, the wires might overheat. This would cause damage to your home's electrical wiring system, or worse yet, start a fire. When an overload occurs in a circuit breaker, the switch from the overloaded circuit trips or shuts off. If a fuse blows or a breaker trips, do not try and fix it. Leave it for an adult.
What other safety measures can I take inside my home?
There are a number of other safety measures you can take around your house to prevent electrical accidents. Check appliance cords periodically. A brittle or torn appliance cord can leave the inside wires exposed. Touching the exposed wires could shock you. Also, the exposed wires can get hot and start a fire. Never unplug an appliance by pulling the cord. Always carefully remove the cord by pulling the plug. Don't run appliance cords under a rug, through a doorway, or anywhere else where people might step or trip on them. Don't place appliance cords near heaters or burners. The plastic cord could easily get hot and melt, leaving the inside electrical wires exposed. Never use an extension cord as a permanent electrical wire. It is not designed for that. Extension cords are intended for temporary use only. When attaching an extension cord to an appliance cord, make sure the two fit snugly together. Just like exposed wires, the exposed prongs get hot and could shock you or start a fire. When using an extension cord, don't wrap the cord around any metal pipes. Remember, metal is an electrical conductor. If you need more wiring or electrical outlets in your home, call a licensed electrician. They will do the job properly, ensuring you and your home a safe electrical system. If you switch on an appliance and it sputters, sparks, or smokes, turn it off and unplug. This appliance is unsafe. Call or take it to an appliance store for repair. Be sure to switch off all appliances when you are done. Many household fires have been started by ranges or irons that were left on and left unattended. Never stick a metal object into your toaster to retrieve a piece of bread. If the metal object fork touches any of the electrical heating elements, the charge would be conducted through the fork and into you. If you must retrieve a piece of bread from your toaster, unplug the toaster first. Water is a conductor of electricity. When operating an electrical appliance, make sure that your hands are dry and that you are not standing in water. Music is wonderful, but never use a radio while in the bathtub or shower. An unfortunate accident could lead to a fatal shock. If a light bulb burns out and you are replacing it, turn the switch to the off position and, if possible, unplug the lamp. When you are screwing the new bulb in, hold it gently by the glass. Never touch the threaded metal or the socket.
What should I do if an electrical fire starts?
If you do experience an electrical fire in your home, never pour water on the flames. The water can conduct the electric charge right back up to you. If possible, cut off the flow of electricity to the fire. The flame should be put out with a fire extinguisher. Every house should have a fire extinguisher handy for such emergencies. If you don't have a fire extinguisher, use baking soda. Call the fire department immediately. Just because you cannot see flames anymore doesn't mean the danger is over. Firemen are professionally trained to know about such emergencies. They will make sure that everything is safe. These measures are important for ensuring electrical safety around your home. However, accidents do happen, and you must also know how to react when one does happen.
What should I do if someone suffers an electric shock?
If someone you know suffers a severe electric shock, you must act quickly. First, if possible, unplug the appliance which is causing the shock. This will stop the flow of electricity into the victim's body. If you cannot safely unplug the appliance, try and remove the wire using some object that doesn't conduct electricity, such as a dry stick or wooden broom handle. Remember, do not touch the person because you will then be shocked. If the victim is not breathing, administer mouth-to-mouth resuscitation. Call an ambulance immediately. Prop the victim's feet so that they are higher than his head. This will help keep the blood flow to his brain. Keep the victim warm by wrapping him in a blanket. Stay with the victim until the ambulance arrives. They will give him trained professional help. Understanding how electricity works and how to act safely around it, both indoors and outdoors, is very important. Knowing how to keep yourself safe from electrical accidents and knowing what to do if one happens will keep electricity working for you and not against you.